Hello everyone, we are group 1.2 and we will be predicting tennis match using network by using the data from ATP matches in 2017. Our project objective is to predict the winner of certain tennis match based on historical data and to locate the most important features for a successful gameplay to determine the most successful strategy for a player. Our data source is ATP matches 2017 dataset. Our data features example are like the personal details, like the personal particulars of player ID, hand, height, ages, ranking, and also the gameplay details in a certain match, like the ace number, first serve won, second serve won, BP save, BP faced, etc. Our methodology includes community detection, bipartite graph, link prediction, and node classifications. Next, I will be introducing our first methodology, community detection. We can first calculate player similarity based on their features, and then create a graph with players as node and similarity scores as edge waves. And then we applied a Graven-Newman algorithm for community detection, and we could identify two main community of players. Their average win rate are different. Why we use Graven-Newman method is because it's suitable for small to medium graphs and with a reasonable resources costs. We run this at around 7 minutes on our GPUs, which provides robust results, while other methods are less robust or may not be applicable to our dataset, as the test pairs are more or less similar. Spectral clustering provides less satisfactory results. And here you can find our located feature importance by applying a random forest on the dataset for the respective communities. And we could find the personal particulars are the most important, like age, points, rank, and heights. And also for the gameplay details, we noticed first serve won and the ace is the most important. Next, I will introduce my groupmate to introduce next method.
To predict whether a player can win or not, we can first create a bipartite graph by dividing the ID and the match results into two independent sets. Top nodes are IDs of the players, and the bottom nodes are match results. An example of 5 players is displayed on the right of this slide. If the ID node points to 0 node, the player lost the game. If the ID node points to 1 node, the player won the game. Then we choose Jacquard coefficient as the similarity measurement. It is defined as the size of the intersection divided by the size of the union of the sample sets. The prediction is done by computing and ranking the similarity of the neighbor set of each node pair in link prediction. Finally, we make predictions according to similarity between players in the training set and the test set. However, after applying all the methods, we found that based on all the features, it is difficult to find enough similar players from training set to match those in the test set. Therefore, we made a little improvement by giving up the bipartite graph, but still utilize Jacquard coefficient as a similarity measurement. Firstly, we take all the variables as a set and calculate the Jacquard coefficient. After finding the K players in the training set with the highest similarity to the players in the test set, we can predict whether the player can win or not, based on the winning situation of K training set players. Here, we set K equals to 5 and obtain the accuracy score of 62.82%. the result is relatively dissatisfactory. The method may be inappropriate for this dataset. Next, let my partner to introduce the node classification.
Well, node classification is the process of assigning labels to nodes within a graph, given a set of existing node labels. So it's a semi-supervised setting. We use these labeled nodes to obtain those unlabeled nodes. In this case, we use two methods. One is relational classifier, and the other is graph neural network. Let's look at the first method. The basic idea is that the win probability of yi is a weighted average of the win probabilities of its neighbors, and there are three main steps in the process. At first, for nodes in the training set, we initialize y labels with win probabilities, denoted by in degree divided by the sum of in degree and out degree. For unlabeled nodes, we initialize y uniformly. Based on the formula on the slides, we update the probability of each node and repeat this step until convergence of each node. It can be noticed that all scores stabilize after 5 iterations, and we can get the win probabilities of each node. Predicted results can be solved by comparing the win probabilities of two nodes. Well, let's look at the second method. The basic idea is to learn neighborhood embeddings by aggregating information from a node's neighbors via edges using neural networks, and the process is shown on the slide. We use 64 hidden layers and 200 iterations and use entropy function to calculate the loss value between the predicted output and the actual label. It can be noticed that after 30 iterations, the loss values become stable. Then we can build a neural network model to predict match winners. Take these two players as for example. We can predict the outcome of a match based on the players' statistical and historical data. Well, let's invite my teammate to show the conclusions.
Our conclusion for the gameplay is that we found the personal particulars like the winner's rank point ages are the most important, while for gameplay strategy, we recommend the player to pay attention to their first serve and ace to achieve a successful gameplay. And for winner prediction, we try various methodology, including bipartite graph, link prediction, and node classifications. And we reached the conclusion that node classification with neural network is the most effective, with almost perfect accuracy match on the test set. And that's all for our presentation. And here is our references. Thank you.